What's going on, everyone? Let's talk about antiderivatives, okay? And so in terms of antiderivatives, or also called definite and indefinite integrals, and I spelled indefinite incorrectly, what originally we were talking about is calculating the area under some function f of x, right, between some values x is equal to a and x is equal to b, right? This is your range. And we were trying to calculate the area under this curve previously using left and right endpoints. Today, let's look at integrals in terms of, conceptually, the reverse of the power rule, okay? And so what I mean by that is that we know that in order to take the derivative of some function, let's call a generic function x raised to the n, right? Taking the derivative with respect to x, the first step of the power rule is to multiply the exponent by the current coefficient, which is 1, which gives you your new coefficient, and then you subtract 1 from your exponent, okay? That's how you calculated the rate of change, or the slope, right? Which came from the derivative. Today, we're going to go backwards. So given this function here, let's call this function, right, f of x. We're trying to figure out what is the original function, called this little f of x, right? Big F of x, little f of x. What is the original function that we needed to take the derivative of in order to get this, okay? And so that's gonna look like this in pink. So I listed it down here, the opposite of the power rule. Instead of first multiplying and then subtracting, we're going to do the reverse and opposite, meaning we're going to do the opposite of step 2, which is adding 1 to the exponent instead of subtracting 1. And then we're going to divide the coefficient by the exponent instead of multiplying the exponent and the coefficient, okay? And it looks like this. So just like this example, okay, we're going to do the opposite. We're going to find the integral, the indefinite integral, meaning that there's no interval given here, right? There's no range of values we're going to assess between. So we're going to find the indefinite integral of this function, nx raised to the n minus 1 with respect to x. The main question that you see down here, you're going to ask yourself, what is the original function, right, that I needed to find the derivative of in order to get this? And so in this case, if we're following what we modeled up here, this is going to be your little f of x, right? And this is going to be your big F of x. When you're doing antiderivatives, you are trying to figure out your big F of x, okay? And so we know that if nx raised to the n minus 1, we had to take the derivative of x to the n. Since there's no interval given here, and this is an indefinite integral, you're going to tack on some constant, so any plus c to your final answer, okay? It's a little bit different when you're given the same problem, but you are also given an interval. So number 2 here is the same. The integral of this function, nx raised to the n minus 1 with respect to x, right? Between the interval or on the interval from a to b. In this case, you don't tack on a plus c because this one is defined, okay? This one is undefined. And so since you're given your interval, you're going to assess your answer, x to the n, on the interval from a to b, meaning you're going to subtract your function big F of x evaluated at b, right, which is here, and subtract that by big F of x evaluated at a, which is this term, okay? And so just keep in mind as we go along, what is the function that we call big X that I needed to take the derivative of in order to get to this function little f of x that I'm given, okay? So in this case, you're trying to find big F of x given little f of x, all right? So let's get into our first example. So if I give you the indefinite integral of the function 2x with respect to x. When you're asked to evaluate this, right, what you're going to do is you're going to look at this and you're going to say, okay, my function that I'm given, my little f of x, right, is 2x. When you're looking at this form, right, when you're looking at this example and this example, think of the function you're given as the derivative, right? And now you're going to ask yourself, what function, big F of x, do I need to take the derivative of in order to get this? So essentially, what is my original function, f of x, or in this case, big F of x? And in this case, let's do step 1. You're going to add 1 to your exponent. So this is x raised to the 1 currently. So you're going to add 1 to that. So this is going to be x squared. Now, you're going to divide your coefficient that you're given by your exponent. So 2 divided by 2 is going to be 1. And 1x squared is the same thing as x squared. So I'm going to leave it. So now we know that big F of x is going to be x squared. But we're not done yet, right? Because we are not given some set of intervals here. So because this is an undefined or indefinite integral, you're going to tack on a plus c, okay, some constant. And that's going to be your final answer for that one. All right, let's go to another one. Let's do this example. The indefinite integral of the function 12x cubed with respect to x. Okay, try that one out. Sweet. So if you're looking at this, we, again, are looking at this as this is my function, little f of x, right, is equal to 12x cubed. And based on what we talked about up here, this is my f prime x, because we are asking what is the function big F of x that I need to take the derivative of in order to get this function, okay? So essentially, we're asking for the original f of x that gave us this f prime x. And so again, step 1, we're going to add 1 to the exponent, right? In this case, 3 plus 1 is x raised to the 4th. And we're going to divide the current coefficient, 12, divided by the exponent, 4. That's going to give us 3, okay? And just in case you want to check, do the power rule on this. So 4 times 3 is 12. Subtract 1 from here is x to the 3rd. So now you know that this is your big F of x. Because the interval is not defined, you tack on a plus c. Okay? And this is your answer for this one. One more indefinite integral, and then we'll have some fun with this. The indefinite integral of 2e to the 2x with respect to x. Okay, this one's a little bit different. So pause the video and give that a try, and then come back and we'll see if what you do and what I do matches. Awesome. So if you're looking at this, a little more work, right? We know in here that we're dealing with an exponential, and we know that the derivative of e to the x, or e to the something, is going to include the same term, e to the something, because the derivative of e to the x is e to the x. And so in this case, you know that this is your f prime x that you are given, just to stay consistent here. And we're asking what function do we need to find the derivative of in order to get f prime x. So we're asking for our original f of x, right? And so we know that the derivative of e to the stuff is going to include the term e to the stuff, okay? In this case, now let's look at what we have so far. If you were to take the derivative of e to the 2x, right, you're going to have to use the power rule, this one in red. You're going to have to take the derivative of first the entire thing, so the derivative of e to the 2x is e to the 2x, and then you're going to have to multiply it by the derivative of just the stuff, right, of 2x, which is going to be 2. And so you're going to get 2e to the 2x. So now you know that this is going to be your big f of x, is e to the 2x. Because the interval is not defined, tack on that plus c. Okay? And then one more, I lied earlier, one more. Let's do this one just so I can cover properties with you. The indefinite integral of the function or expression 5x to the 4th plus cosine of x with respect to x. Okay? So pause the video and take a look at this. Awesome. So if you're looking at this, there are two terms in here, right? And so the same way, it's the point I wanted to do with this one. If we're asking you to take a derivative, right, of some function f of x plus some function g of x, right, you know that you need to distribute this derivative to every term in that expression. Well, in this case, same thing here. You're going to apply the integral to every term in the expression. So this can be also written as, right, first of all, let's write this as f prime x, right, is equal to 5x to the 4th plus cosine of x. And then the main question, what is the expression or what is the function big f of x that we're going to have to take the derivative of in order to get this f prime of x, okay? And so you're going to consider these separately. So this is the same thing as, I'm going to continue this line down here, is equal to the indefinite integral of 5x to the 4th, right, the first term with respect to x, plus the indefinite integral of the second term, cosine of x, with respect to x. And now we can consider them separately. So what is the function that you need to take the derivative of in order to get 5x to the 4th? You add 1 to the exponent, right? So this is x to the 4 plus 1, which is 5. Divide the coefficient 5 by the exponent 5, which will give you your coefficient here, which is 1. Okay, so x to the 5th plus, you know that the derivative of sine is cosine. So this is going to be sine of x, right? But because, again, the interval is not defined for this, you're going to tack on just 1 plus c. Okay? And this is going to be your final answer for that one. Okay? So if you've been able to follow so far, good job. We've covered the indefinite integrals. We've covered this one. So now we're going to jump up and do indefinite integrals, okay? And so let's do that. On this page, let's do example. Let's do the same functions so that we can see how it differs. So now I want you to take the definite integral of the function 2x with respect to x, okay, on the interval from 0 to 2. So same steps as before, right? This is going to be considered our f prime x, right, is equal to 2x. And now you're going to ask, what is the original function, big f of x, that I needed to take the derivative of in order to get 2x, right? So you're essentially asking for your original f of x that you used to get this f prime x. And we said before that that was x squared, okay? We're not going to add on a plus c because this is a defined interval, okay? It goes from 0 to 2. So what we're going to do is we are actually going to assess this answer from 0 to 2, meaning we are going to assess big f of x, which is x squared, going from x is equal to 2, right? So this is going to be 2 squared minus big F evaluated at 0. So 0 squared. And when you do this, it's going to give you a final number answer, which will be 4. Okay, but I'm going to leave it in this form so it's simple and you can see it. So let's do another. Let's do the definite integral from 0 to 3, okay, of the function 12x cubed with respect to x, okay? And again, we are going to look at this as we are given our f prime x, right? So our f prime x is 12x cubed, and we want to know what is the original function big f of x that we needed to take the derivative of in order to get this f prime x. Okay, and we said again, we're going to add 1 to the exponent. So x to the 3 plus 1 is 4. Divide the current coefficient, 12, by your new exponent. 12 divided by 4 is 3. That's your new coefficient. Now, instead of adding on a plus c for an undefined interval or an indefinite interval, we're going to assess this from 0 to 3, from 0 to 3. And again, that's going to be big f of x, which is this, evaluated at 3. So 3 times 3 to the 4th minus 3 times 0 to the 4th. And when you work that out, that'll give you a single number answer. Okay? Let's do another. So let's do this one. The definite integral from 1 to 5 of the function 2e to the 2x with respect to x. Okay? One more time, we are going to consider this, that we are given our f prime x, right, which is 2e to the 2x, and we're going to ask what is the original function, big f of x, that we needed to take the derivative of in order to get this f prime of x. So what is the original f of x? And we said that that was going to be e to the 2x. Okay? E to the 2x, since it's on a defined interval from 1 to 5, we are going to evaluate on the interval from 1 to 5, which means big f of x evaluated at 5. So e to the 2 times 5 minus big f of x evaluated at 1. E to the 2 times 1. And when you do this, you are going to end up with a single number final answer. All right. So one more. Let's do, and then I'll stay consistent with the coloring because I think it's pretty neat. The definite integral from 3 to 10 of our expression 5x to the 4th plus cosine of x with respect to x. Okay. And so, again, this entire expression is given to us as our f prime x. All right, so this is 5x to the 4th plus cosine of x. And we want to know what is the big f of x, or our original f of x function that we needed to take the derivative of in order to get to this point. And we said that that was going to be the integral of the first term, 5x to the 4th, which was just x to the 5th, plus the integral or antiderivative of cosine of x, which was sine of x, right? Because the derivative of sine is cosine. And we're going to evaluate this entire thing from 3 to 10, meaning this entire thing is big f of x, remember, right? Big f of x. And so you're going to have to evaluate big f of x evaluated at 10 minus big f of x evaluated at 3. So don't get mixed up because there's two terms in here, okay? So for the first one, wherever you see an x, put in a 10. So for this first term, it's going to be 10 raised to the 5 plus the sine of 10, right? This is only f evaluated at 10. Now we have to subtract big F evaluated at 3. Wherever you see an x, put a 3. But now you have 3 raised to the 5th plus sine of 3, okay? And that was F, big F evaluated at 3. Now when you do this and put this in a calculator, again, you're going to get a single value answer, and that's going to be it for that, okay? So if you were able to follow, good job. If you weren't, totally fine. Go back and see where you got stuck, okay? If you have any questions or comments, please leave them below, and I will get back to you as soon as possible. And so this was antiderivatives in terms of defined and undefined intervals.